Okay, so no secret, AI, literally everyone is talking about it. In terms of the actual implementation side of things, just interested in terms of I'm guessing there must be quite a lot of pitfalls, obstacles to success because there are, you read various reports, etc. A lot of AI projects struggle to, if you like, succeed or at least gain momentum early on. So what's going on?
Yeah, it's interesting. So AI as a whole, obviously, it's formed on data, and you need a good data repository to feed data, or sorry, to feed AI as a whole. We It's interesting because we started off with the idea of business intelligence or business analytics, and that was usually manually fed with data. Brought in, things would get put in, and then business outcomes would come out of it. AI is interesting because AI can learn from what is going on. It's a lot quicker, it's a lot more nimble, but it comes at the expense of needing a repository of a tremendous amount of information so it can do something. And that seems to be the struggle with AI at the moment. My background, I came out of a lot of the facility space, so facility management, building technologies. And building technologies have done analytics for decades. We've had data coming out of buildings probably for the last 40 or 50 years. The problem was it was very siloed data. So the building management system was really focused on HVAC for the most part. Then you would have a lighting system in a lot of buildings. The lighting system would be very focused on the lighting side of the equation. You'd have Wi-Fi systems, same thing. The problem was you had this siloed approach. And so everything was holding its own data, and then it was using it for its own specific purposes. So when you look at, say, a lighting system, its primary focus was really energy efficiency and energy management. It was a control system, and yes, there was switches on the walls, but really the meaning behind that was to say, well, after someone has left the room, after 10 minutes, let's turn off the lights because that saves energy. The problem is we have all of this data, and there was a significant amount of duplication of data. Let me give you a great example of this. In the average office building, you have conference rooms, and you have meeting rooms, and you have individual offices. In each one of these, there is probably 3 duplicate sensors doing the same thing on the same network, doing pulling in information saying, hey, someone's in the room. Well, what are those systems? Well, the HVAC usually wants to know because it wants to turn off the heating or cooling if someone's not around. The lighting system we just talked about, same exact problem. And the other one may be a security system, wanting to know if someone's there or not. You look at the core technology of that, and you say, well, wait a minute, it's a motion sensor. Why are we putting 3 in? Why are we going through all of the labor and expense to do that? And we're getting the exact same data. Now, the reason I bring this back to this siloed approach is that that information is super interesting to other systems. And up until probably about 10 years ago, when this started to break down, no one thought of saying, hey, we have a lighting system in this building. I wonder if we could use that data of someone being in a room or not for another purpose. And then we don't need to go through the expense of putting in a second sensor for HVAC and a second sensor for security. It wasn't even thought of. And a lot of that comes down to how the construction industry has built things. But this comes back to AI because we only think of the idea, say, lighting, as saying, well, that's lighting technology. It's a lighting trade. It's super specialized. Yeah, it is in some respects. But the data isn't. The data has very valuable purposes way outside of just lighting. And AI, if AI engines can be fed this information, we then have a single source of truth, a single location that we can go to say, hey, I want to look at this building a little differently. We have currently data sets that are getting fed into a data lake for analytical purposes of those 3 different trades, HVAC, lighting, and security. Just say we have that. Well, you know what's really interesting? We have this high rise that we think we're spending too much energy on because we're starting the boilers up too early in the morning to heat the building. And if only we knew how many people, or if people are on every floor at a certain time every day, we could think through this and say, well, maybe we could change the startup time. Maybe we could save some money on that. Well, if we went back to the traditional way of thinking, then a fourth trade would come in saying, hey, we're an analytics company. We're going to start putting sensors in to figure out if people are on the floors. Well, you look at the project of putting a sensor in on every room of every floor in a 50-story high-rise in New York City, you're looking at a couple $1,000,000 of labor and work. But the information's already there. The lighting system has it. But the lighting people aren't thinking this through and saying, hey, we're involved in the heating and cooling of a building. Let's offer them that data. It's the breaking down of the silos. And so this is where AI has all of this potential. What was very difficult and segmented before, through a centralized location, you can almost dream up the idea of saying, well, we have all of this data. How can we benefit from this through different angles?
Okay, and in terms of how best to address what you've eloquently described there, the sort of disjoint of data sources and the AI systems, things like data integration, data storage challenges, in terms of getting informed, ultimately, as you outlined, you want informed our responses. So how best to go about addressing this disjoint, if you like, between the data sources and the AI systems that want to ingest it in a meaningful way, if that makes sense.
Right. That's been the challenge, really. And I am talking about building technologies. It's the area that has really changed up until, well, it didn't change till about 10 years ago, was IT technology was always completely separate from building technology. And that happens in a number of different fields. And you can even go down to the restaurant level of saying, well, I've got this quick service restaurant and all of this different equipment. That's different. That's not IT related. There has been a normalization. It used to be that everything spoke its own language. And so it was very, very hard to figure out what the data was, and how to pull it together. And that was a lack of an ontology, a lack of a structure to say, how do we normalize this data so we can look at it in a cohesive method, also understanding that we may not have the questions yet, but we want to make sure that we have the data set to be able to harvest it for questions now and in the future. A lot of industries have started standardizing on some protocols. This is great. And those are industry-specific protocols. So in the building management space, you have things like BACnet and Modbus. In the IT space, which has super excelled, you have Ethernet, which is a wonderful thing, the TCP/IP stack. And over time, the cost of goods for network connectivity, the reason all of these legacy protocols exist within different industries was typically about cost. It was very cheap. A lot of these protocols you could implement for $1 or $2, and then they were serial protocols, very simple technology. A lot of drawbacks. They weren't very scalable. They were very proprietary in a lot of cases. And you couldn't shift these around and merge them well because there was really no structure about them. They were made for one purpose, and typically that was diagnostic purposes. That's heavily begun to change. Things are becoming network native by default, and that is thanks to the world of Ethernet and the computer technology. We now are jumping on the Ethernet wire and actually using common computer technology in what was small devices at the end. And so you think of things like thermostats. Thermostats are now network native. They're not much more expensive than their old counterparts that were proprietary. You think of things even in, go back to the kitchen example. Who knew that deep fryers are now networked, because they have a tremendous amount of information that you can pull out and use, and they have their own monitoring softwares for them. So quite a bit of this is a standardization that has occurred somewhat organically, but also by demand of customers. And this is one of those areas where we've almost gotten it backwards. It used to be that when technology evolved, it would be built, and industry or large companies and commercial applications would use it first, and then it would trickle down to the consumer level. That's different. Smartphones started this, but really our reliance on technology has pushed this from the consumer level to the commercial level. So people in commercial settings using their phone, getting acquainted with the idea that, hey, I can now pull up data on my phone. I can use things, all because it's enabled by cellular technology, Wi-Fi, and in the end, Ethernet, really enables this growth of interconnectivity that's becoming expected by markets. So we're entering into this era where the connectivity is expected. Companies, manufacturers in particular, can't get away with saying, hey, you're putting our stuff in, we're only going to work with our stuff. Because that is being seen on a very public and grand level that just doesn't work. You need the way to be able to pull things together and use other systems in to make outcomes for your job, your company, and all different facets of your life.
Yeah, so I guess what you're describing there is the importance of being able to centralize operational data. Again, for if AI systems are going to do their job, and you mentioned at the top of the conversation, I think about breaking data silos. I mean, I know that's been talked about for years and years, and it potentially is beginning to happen, but it's still
Yeah.
happening at a slower pace than necessary. But as you say, the importance is data can be obtained from old, new systems, distributed, centralized sites, and all manner of different devices, I guess. So I guess just, re-emphasize or elaborate on just why it's so important to have this, if you like, one pool of centralized operational data with everyone, heading in the same direction as opposed to still doing their own thing to a certain extent.
It is. It comes down to usability, and the idea that these old building systems, ASHRAE, which is an organization that is for facility management, and heavily specializes in HVAC and lighting. It's a trade organization. Says there's an average of 13 different systems in a building. So those are different devices and communication layers, all things linking together. We talked about that. HVAC, lighting, great examples. The problem is these are individual software packages. These are individual systems that a human being then needs to interact with directly. So you go up to a computer, you log into a piece of lighting software, you're looking at the lighting system, and it's very designed around what the manufacturer thought a user would want from that experience. And most manufacturers are concerned about the diagnostic and health of the building, in some cases, efficiency. But we don't live in a siloed world. We live in a connected world. And lighting and HVAC, they go together. They should work together. So we are talking about the idea of a single pane of glass. Instead of having people that understand 13 different software packages, understanding that even in a facility, that facility manager will not be there forever. There will be changeover. There will be more than one person. There'll be several. When you look at the large management companies of buildings that manage these, the companies like the CBREs and the JLLs and the Empire Real Estate Trusts of the world that manage these huge portfolios of buildings, having a different piece of software for every different type of system, and then to add to that, every different brand or manufacturer of system is entirely unmaintainable. Even the most smart people in the world cannot understand all of these trades all of the time and then pass that information down. It's an impossible task. So by saying that we can solve the problem of gathering this data, organizing it in a way that a single piece of software can then make these decisions and analytics for a human, it allows us to really have access to this data on a much more liberated level. by people that aren't just experts in one or two pieces of software. All of a sudden, you can have an expert on a building or a facility type or a market type without having to understand all of these underlying layers of things that it's just not maintainable.
And I suppose then the next obvious question is, what does such an accessible data foundation for AI applications, which we're focusing on, what does it look like? What? And I guess the sort of part two, if you like, is DSIM, which in the data center industry has been a much, should we say, used and abused word. We've had different iterations, and I know it's beginning to sort of regain or gain some credibility, should we say. But so just what does this foundation look like, and where does DSIM fit within this accessible data foundation, if that's the right term?
Sure. Yeah. So there's two parts to that question. One is it should be understood that building systems as a whole, and we'll even talk in the data center market, these are not replaced easily. A rip and replace philosophy simply can't exist, because when you look at the average BMS or EPMS system within a building, you expect the lifespan of that thing to be 20, 30 years. This isn't like replacing an iPhone. The costs, the ROI on replacing one of those systems is astronomical because of the labor. And honestly, as we move into the data center market, the risk of doing that. So how this looks from a bigger perspective is you need to accept the old and you need to be able to supplement with the new. Buildings have building management systems. A lot of manufacturing is EPMS style systems and energy management systems. And then data centers have a combination of building management and DSIM systems, because DSIM is a subset. Yes, there is some environmental control, but that it also is dealing with much more of things like assets and other factors that are special with the data center market. I think an important thing to say here is that the systems themselves as they exist are not bad. They work, and they shouldn't be replaced for the most part. We can talk about greenfield and new construction, but the fact is new construction is occurring, but the old systems should live on. Remember, they have been gathering data for the most part for 40 years, but no one's been looking at it, or no one's cared to use it. So where this really progresses is, well, what do you do with this then? These old systems are very good at absorbing old data. You go back to the thermostat example. Yeah, maybe you don't want to replace all those thermostats. You don't want to replace your VAV units because they're not network connected. Great. They're communicating on an old protocol that the BMS is handling phenomenally well and dealing with the control architecture, but it doesn't really do well on the monitoring side. This is where the idea of commercial IoT applications has really stepped in. And these are software that goes on top of. So think of it as a layer. You have all of these separate systems, regardless of age, generation, or manufacturer. And an IoT platform, particularly a commercial IoT platform, and to differentiate from the home IoT platforms, the Alexas of the world, the Google Homes of the world, allows you to sit on top and then communicate with all of these subsystems, extracting the data, and then moving it to a data structure, that ontology, being able to rationalize and say, hey, I have 4 HVAC systems, really. They're by 4 different manufacturers. They've been installed over the last 23 years. But they have data. Let's pull that all in, and we know they're all HVAC systems. So how do we organize that data structure, move it to a data lake in the data cloud to turn it into something that then is a mineable data collection for AI about HVAC? Then on top of that, we look at the lighting systems, and we may have 4 or 5 different lighting systems across several facilities. We can pull all of that in, organize that into a structure that can also be fed by business intelligence tools, including AI tooling, to do that. This is about creating an extrapolated layer up to allow a data lake to be harvested and an evolution to using that data, not a revolution. It's all about creating a data lake instead of a data swamp. And right now we have a huge below sea level swamp of data that is floating out there in little pools all over the place. Being able to pull this together without rip and replace seems to be the key. And the really great part about it is the financial aspect of it. You are not replacing anything. You are simply supplementing and doing this at the cloud layer, to be honest, because that's another area where IoT platforms have really excelled, given they're natively Ethernet, they're natively on the internet. You can look at more than one building. And that's really the key to a lot of benchmarking and analytics in the AI world that we've seen is great. One facility, you can certainly do a lot with that data by pulling together all of this data from all the different things that are happening in it. But boy, it gets complicated when you start saying, you know what? In my data centers, I don't have just one data center. I have a dozen. Oh, and then I have edge data centers, which are small unmanned facilities out in the middle of nowhere. I need to look at them too, not just for troubleshooting, but I want to be able to benchmark all of this and say, where are my outliers? What's going wrong here? And can I now start introducing preventative and predictive maintenance instead of just triaging problems that the DSIM is telling me about? I hope I answered all those questions. That was sort of all over.
Very much so. And I mean, then the next one would be what, in terms of what we've been discussing, how is it that yourselves, Radix IoT, how can you help end users with this, as you say, turning a swamp into a data lake, if you like? We've got AI automation, I guess. What is it that you bring to the party?
Yeah, we focus on four markets in general. We're very heavy in the data center market. So we work with a lot of DSIMs. We can also operate as a DSIM, but as I said, a lot of data centers have a DSIM. They don't want to run the risk of changing it, but they also know that they're not getting this holistic view to be able to make actionable changes across their entire portfolio. And I use that word portfolio very carefully because most data centers are more than one building and they're more than one location, and sometimes they're international as a scope. The other one that we work heavily in is telecommunications. So you think of the idea of lots of tiny locations that are autonomous, that need to be monitored and managed. They don't have a lot of data, but the data is critical. And it's usually in the tens of thousands of little locations to keep cellular infrastructure operating. The other one is energy, and this is one that's been growing, both traditional and alternative. You look at midstream, upstream, and downstream in that equation, and we certainly play in both the upstream and midstream categories. So both the production, whether that be wind, solar, or traditional management of extraction, all of that is very customizable and needs to be customized to specific applications. But then when you shift that and either bring it onto the grid or move it through a pipeline, a significant amount of monitoring and other systems come into play. And then the last thing is CRE, commercial buildings. And that is one where you can say that's exceptionally broad, but some of the examples I've given, a commercial building can be anything from an office campus to fast food restaurants, to the idea that you have a tremendous amount of data in a very small restaurant, but you happen to have 100 or 200 of those, and you want to look for outliers in there. We bring to the table the idea that we have a commercial platform that can pull in the data you already have. You have systems, we know you have data, and depending on your company size, you can do something with it. You're probably just not doing anything with it now. At best, perhaps you're running reports. There has been a push recently to say, hey, we know we have information, particularly from our building management system. Can we at least run some reports? But then you look at it and you say, I've got 10 buildings. I'm running reports on 10 buildings. What am I looking at? What am I looking at? What am I looking for? And that's where the manual labor comes into play. Excel spreadsheets can only go so far as you scale. And this is where we step in. We offer the package to, one, build that ontology of all of that data from all the manufacturers. We're not tied to any single manufacturer. We work with any manufacturer speaking a standard protocol. As I said, thank goodness, protocols have become a more standard thing. We pull all of that in, and then we shift it to a cloud service that allows all of this to get built, organized. And then we also offer the tooling that allows that data to be analyzed for use. And the interesting part of it is there are a tremendous amount of microservices out there right now. And these are software as a service firms, but they're very specific on saying, hey, we focus on restaurants. You give us data, we'll help you with your restaurants. Or you run a hotel, we have great ways to deal with energy analytics in hotels. But most people don't fit cleanly in all those categories. The tooling that we provide allows an easy, intuitive access to all of this data and allows people to introduce the knowledge that they know, say, I'm looking for very specific things. Help me find these specific things with that data. I'm not going to say that we're the only people that can analyze data, but organizing that data in a way that makes it efficient is very challenging. And that's an area that we've spent years figuring out how to do to build that ontology to make AI tooling possible.
And in terms of that analytics piece, how much do you offer to folks to do, automated so that you can start looking for patterns, or are you relying on human sort of knowledge to, a bit like ChatGPT to ask the right questions and then the information is brought back? Or can you help automatically just, interrogate the data and bring up patterns that people may not have thought about? So, obviously if humans are asking the questions, you're limited by what they come up with. Whereas if you sort of AI and automation can just interrogate it in multiple ways at speed and bring up patterns that, as I say, humans maybe hadn't even thought about. So, where
Yes. So we represent the patterns. We look for the patterns, and it allows people to go in and say, well, what patterns am I looking for? So there is a personal aspect to that. And we have found that in general, a lot of these companies have very interior knowledge of their operations and have been looking for things. They know there's problems, but they can't understand and figure out how to solve them. We offer that data and the tools to visualize that. Now, to answer your question, the AI side of this, we have focused on allowing our data model to be the AI tool set, the repository for the data. We feel that there are a lot of AI tools out there right now. And so we wanted to give the path of least resistance for all of these data tools to be able to access that data. So we have gRPC and a REST API that is Swagger compliant or Open API compliant, that allows the harvesting of this data and the learning of our ontology by AI tool sets. We have not built in an AI tool set as in the actual answering the specific questions, because in almost every case we found, people are looking at first at a very basic problem. I would say that 80% of our customers that come to us are looking for triage management. They just want to know when something broke. And another subset are looking, hey, we want to figure out how to save some money on our utility bills, whatever we may, whether that be water or gas or electricity. But the minute they start seeing this data and start introducing, okay, well, we can find this really easy. This is an easy query to set up. We can build dashboards around that, and they can build dashboards around that, the flexibility. They start saying, wait a minute, we have some other use cases. We realize that perhaps our generators are failing, according to the manufacturer, about 3 years ahead of time. They need significant maintenance and a rebuild. Well, that's interesting. So let's start looking at some of this, not just real-time data, but since we've been storing all of this over a long period of time, let's start putting in some query information to say, well, let's look at anomalies that are happening across all of your systems to try to find outliers so you can start going down and troubleshooting those. Now, that's something that you could say you could try to have an AI tool look at, but all of that information that they know and all of those questions that are leading to that answer are things that are usually in people's minds. Facility managers, a low-level facility manager understands and says, hey, this gasket seems to be burnt out, and I've seen 7 of these over the last 4 years. That wasn't really recorded anywhere, perhaps in a purchasing record somewhere. But being able to look at that and introduce that information and say, well, what other factors are involved when that's happening? What happens 6 weeks ahead of time of that failure? 6, 12 weeks? Was there a significant power outage, or was that generator cycling for some reason? Or was there an electrical event in a manufacturing plant where they happened to be doing an upgrade of the manufacturing line, completely disjointed from this other system, but we still have the data, and say, hey, there's correlated events here that perhaps are involved. You should start looking at these. This isn't to say that we're not getting involved in AI tooling. We absolutely are, but we have felt that being able to interface with external software applications and AI tooling is the best approach at the moment, because it's a missing market. This gathering of the data is all of these great companies out there are making fantastic AI analytics tools down to niche subjects. And I worked for one for a while. Getting the data is the most expensive, complicated part, and usually where they fail, because they can't get the breadth of the data without investing too much into the gathering technology. So we thought, well, we're going to solve that gathering ontology problem.
And maybe then, for folks who are aware of the situation we maybe started the conversation with, they've got all these different systems of varying ages and usefulness, etc. What do they need to do to come up with if you like, a successful strategy to get to the sort of point you've described, where they are pooling, centralizing operational data, and then being able to make some useful, meaningful business decisions? What is involved? Because often these projects, back to our silos, unless someone owns it and everyone buys in, it's maybe not going to work that well. So just what are the must-haves, if you like, in a successful strategy?
Knowing what you have is really the first step. I've seen a number of people who have said, boy, this would be great. I would love to, gather information. You mentioned one word that was very interesting, buy-in. And that is often a very difficult task to say, we're going to put in an IoT platform, we're going to pull in trade information from all of these different systems. And there's often a lack of buy-in to that, because I don't really, some of these trades you don't want to get involved with, because you don't want to break what's working. But there's a reason that people usually are talking to us, and that involves 1 or 2 of these trades at first. The cost of entry is very low, by the way. So long as you're not dealing with replacing, say, a whole building management system, lighting system, water system, whatever. The idea of putting it in IoT, commercial IoT platform above this to start looking at the data is fairly inexpensive. And that is usually a starting point to say, we have issues in 1 or 2 areas. This is what we are looking at. We're having issues in our backup power systems. We're having issues at the PDU level, that we need a better way to analyze data. Let's start there. We'll start with that information. Typically, with doing that, you can rapidly set up something to start monitoring that solution, and then you start looking at adjacent trades, because notoriously things come out and start looking like, well, maybe it isn't us. And in electricity, this is a huge one, because you have several usual subsystems. You may be doing great metering, But then you start looking at your generators, and if you have a portfolio of generators or alternative energy systems, and they're all different systems, you're like, huh, well, our original problem was it seems like we're having power quality issues on Tuesdays at 5 p.m. regularly. Maybe this isn't the mains coming into the building. Maybe this is something we're doing. So maybe we should tie to the manufacturing line and start looking at some areas there. So it grows. It grows out from there. That is one approach. The other one is they seriously do know exactly what they're looking for, and they know that there is problems in the facilities. There is no economic incentive to start replacing things, or worse, they've started replacing things and still haven't found the issues. So entering in, the great part about these platforms too is you're not adding hardware. Traditionally, you're able to get data from these separate systems directly up to a cloud ecosystem quickly. In some cases, a piece of hardware is required, and that's usually in areas which have legacy equipment that need to be bridged. So basically, you're bridging from some legacy protocol to TCP/IP and then pushing it to the cloud. But to really focus, it's knowing what you want out of this style system, and then really knowing what you have. There have been so many cases where we have gone in and they know they have a problem. They know that an IoT platform probably will help them address that problem. But then you ask, well, what systems do you have here that you need to pull in? And that's usually an area that people don't know. They may know a system exists, but they don't know what's connected to that subsystem. They don't know the type of data they're getting. They've never looked at it. Perhaps even it's old enough that the software that came with it, or the software that they're supposed to be using to monitor it, isn't even supported anymore. That's a fairly common problem, where you find that one facility manager perhaps has a laptop that's been sitting in a closet running Windows 7 that was used 10 years ago and was set up specifically for the purpose of that single software. So all of this, though, is very resolvable. It's really identifying what your problem is and then what you have now to offer data.
Just maybe following that up, is there a particular job function title that is best positioned that in your experience to come, or does it, I know obviously different titles, different places, or do you need board level, somebody there to drive this project? Is it that significant, or is someone slightly lower down the chain, should we say, command can grab this? Or just your thoughts, I suppose, as to where the responsibility lies.
It is interesting. That is a very broad answer. In a lot of cases, it depends on the size of the organization. We often have engagement from directors of facility management. We have sustainability initiatives that are built around our software. So sustainability managers, directors of sustainability. In some cases, those have been very interesting because all they're looking to do is simplify their reporting for ESG reporting. They know they have the data, but the reporting is so complicated to do manually that being able to generate these reports more automatically because they have the data sets to do it saves a tremendous amount of time. And then usually they start looking at it saying, whoa, great, this was great, but why are those 3 buildings consuming 14 times the water of the other ones that are about the same size, shape, and are in the same geographic region? So that's, again, where you start seeing this progression. There is certainly for larger companies when you're dealing with larger initiatives, and I'm speaking on the probably telecommunications angle quite heavily, and somewhat in the data centers, where there is a concerted initiative where they want to make sure that they are meeting SLA requirements, the service level agreements. And that is where a financial consequence comes into play. And a lot of these can be pushed by executive or C-level people to say, we need a better way of managing this. because losing a minute of uptime is going to cost us X amount of dollars, and that is unacceptable. And even if the system is running as it is with an existing DSIM and the existing solutions, we need a second layer of data to be able to not only show this and triage it, but be able to generate proof to our clients. So a sales aspect can come into play here. Being able to generate proof that we are meeting those SLA requirements over time.
Okay, we covered a lot of ground, and it's been great to chat. Some brilliant thoughts and insights into what's clearly a rapidly developing area. It's been fascinating. So, Mike, I really appreciate your time today. Thank you very
Thanks
much.
for having me. I really appreciate being here.